Ever pondered the concept of vectors being exponentiated? It's a fascinating exploration into the realms of mathematics, where vectors, numerical quantities defined by both magnitude and direction, take on a whole new dimension. In the world of geometric algebra, vectors can be exponentiated using the exponential function. You see, geometric algebra is rather unique. It allows for the combination of scalars and vectors, something that traditional vector spaces don't permit. So, how does this work? The exponential of a vector, let's call it v, is defined as exp v equals e raised to the power v, where e to the power of v represents the exponential series expansion of v. The beauty of this is that the expansion converges for any vector v in geometric algebra. Quite remarkable, isn't it? Now let's shift gears and move into the world of Lie groups. What's a Lie group, you ask? Well, these are groups that have a smoothly varying set of linear transformations, known as the Lie algebra. Within these groups, vectors can also be exponentiated. The exponential of a vector v in a Lie group G is defined as the element of G that corresponds to the tangent vector v at the identity element of G. It's a bit more abstract than the definition in geometric algebra, but it's still well defined for certain Lie groups. Next, let's venture into the realm of linear algebra. Here, exponentiation is primarily used for matrices, but it's also possible to define the exponential of a vector. This is done by considering the vector as a column vector and then exponentiating the corresponding matrix. It might be less common than the other two methods, but it can prove useful in some applications. Now, you might be wondering where all this vector exponentiation is put to use. Well, in geometric algebra, it's used to represent rotations, boosts, and other transformations in three-dimensional space. In the study of Lie groups, it's used to delve into the properties of these groups and their Lie algebras. Robotics also utilizes vector exponentiation to model the motion of robotic manipulators. And in the realm of quantum mechanics, it's used to represent the evolution of quantum systems under time evolution operators. So there you have it, a whirlwind tour of vector exponentiation in geometric algebra, Lie groups, and linear algebra. From abstract groups to tangible robotics, the concept of vector exponentiation is a mathematical tool with a multitude of applications. It's a testament to the beauty and complexity of mathematics, where simple concepts like vectors can be transformed into powerful tools for understanding the world around us.